All right, guys. We'll finish up. We're finishing up the note sheets with addition and subtraction today. We do have one more part of 4.2 to cover, or 7.4 to cover tomorrow. And that's going to be dealing with, I put rational fractions on the board, but really we're talking about complex fractions. So we'll have fractions inside of fractions and working with those there. Now, for these here, we're not going to be messing with the numerators first. Because as we can tell from looking at the two denominators, well, they're not the same. Because x squared minus 3x plus 2 is not the same as 2x minus 4. So what we need to do is factor the two denominators as far as we can, and then see what we need to do to both of them to get them to be the same. Which one do we want to factor first? Two x minus 4, because we just need to factor out a 2. If I factor 2 out of 2x, I'm left with x minus 2, because a 2 factored out of 4 would give us 2. Now for our x squared minus 3x plus 2, well, we'll need 2 sets of parentheses. Now since the 2 is positive, the signs are the same and they match the sign of the middle term, which would be negative and negative. Factors of x squared are 1 and 2, because those are the only factors for 2 and x. So it does work out. So, do we want to start with the rational expression on the left first or the one on the right? So if we look at the rational expression on the right, we need to multiply the top and bottom by something so that the two denominators here are going to be the exact same. Now, most books are going to go about it. We need to look at the least common denominator, essentially the least common multiple for the two denominators, and then write that out and then go about trying to figure out what's going to make them be the same. I think the easiest way to look at this is look at both of them. And so we're starting out with the 2 times x minus 2. What is it missing that the other one has? Well, the x minus 1. So we'll multiply top and bottom here by x minus 1, because the one on the left has x minus 1 and x minus 2. The one on the right has 2 times x minus 2. They both have an x minus 2 one time, so we're good there. The one on the right is just missing the x minus 1. So I'll multiply it for top and bottom over itself. Okay, so now the right side does have everything that the left side has, yes? Okay, let's go the other way around. Let's see, what is the left side missing? It would be the 2. And that's the main way I think of this here, is because I look at the two denominators or the multiple denominators and see what are they missing? What do the other ones have that it doesn't? So for the left, it was missing the 2. The right was missing the x minus 1. And again, when we multiply each one of these by the same thing on top and bottom, we're really just multiplying by 1. Now the denominators we're not going to actually multiply through, because here we're just going to say 2 times x minus 1 times x minus 2. The other one we're going to say is 2 times x minus 1 times x minus 2. And really the order in which we write these isn't too overly important. I would make sure any of the terms that are being multiplied by everything, so here the 2, that greatest common factor out front, kind of stays in front. It's going to be a little bit easier to work with if it's there. And the order of our parentheses, the x minus 1 and x minus 2, really doesn't matter. Write them however you feel, as long as we have both listed. Now the numerators we will multiply. So for the one on the right, we're going to be distributing the 2. So 2 times 5x is minus 2, because 2 times 5x would be 10x, and 2 times negative 1 would be negative 2. So we get 10x minus 2. On the left-hand side, or right-hand side, we're going to distribute this here. So we'll do, well, it'll 2x, what's that here? Okay. Come on. 2x times x, negative 2x times x, and negative 2x times negative 1. Well, negative 2x times x is squared. Negative 2x times negative 1 is plus 2x. Then do the same thing with negative 1. Negative 1 times x is negative x. And negative 1 times negative 1 is plus 1. Well, here we're going to have 10x minus 2 over 2 times x minus 1 times x minus 2 minus 2 times x minus 1 times x minus 2. And we can combine our like terms, so we'd have negative 2x squared, because there's no other term with x squared. Our 2x minus x is going to be plus x, and then minus 1. Now we can go on and subtract these here. Now the first term isn't going to really change because it's just 10x minus 2. And what we're doing is we're subtracting everything in the second numerator. So we have negative, or subtracting negative 2x squared plus x minus 1. And the reason I do this and write it in parentheses is, again, just as a reminder that everything inside that second set of parentheses are with the 2x squared, the x, and 1, the signs are going to change because of that subtraction. Because when we're subtracting these, really what we're saying, and we kind of sometimes forget about it, is that we're subtracting negative 2x squared. Well, that negative and negative would make a positive. So really we have plus 2x squared. And if we're not careful, and if y'all are working through these and rushing through these, I've seen it happen a lot, is next y'all will write plus x minus 1. Because we need to distribute that negative not just to the 2x squared, but also to the x and 1. So we wouldn't have positive x anymore, we have, because we're subtracting positive x, which is going to make it look like negative x. And if we subtract negative 1, the negative and negative again would make a positive. And this here is going to be over 2 times x minus 1 times x minus 2. Well, now we can combine like terms. Well, 2x squared is by itself. But we do have negative x and, which is plus 9x, because the 10 is going to be bigger. And negative 2 plus 1 is over 2 times x minus 1 times x minus 2. Now we do need to make sure that the numerator does not factor in any way, shape, or form, and that there's not a greatest common factor. Well, there's not a greatest common factor between these three, because all three don't have variables, and 2, 9, and 1 don't have a number that's divisible into all three. And, well, the middle term of 9x is a little too big for us to use the factors of 2 and 1 to get anywhere near. So most likely this here does not factor. So that there is our final answer. Any questions on any of this here? I find this placement kind of funny because we worked through the last two, which were not terrible, but they were at least had some pretty intensive process of finding the least common denominator to get the denominators to be the same. And then we come across this one here. So I'm going to rewrite it so that I have a little bit more room. Because we have 3 over, well, 4x and 7 don't simplify at all. Well, we could look at the 7 first. What do I need to do to get the 7 to be the same as 4x? That'd be nice if we could do that, but we'll have to multiply by something. So 4, 8, 12, 16, 20. We have 7, 14, 21, 28. Yep, because if we go 2 more with 4, 28 is the first one that they both become the same. So we need to get 7 and 4 to be 28. So 7 we need to multiply by 4. And the 4 we need to multiply by 7. Okay? Is there anything else that the 4x has that the 7 doesn't? X. We need an x. And that's probably one of the few times we'll ever say that. That you need an x. It's all right. So, for the one on the right, we can multiply top and bottom by 7. So 7 times 3 is going to be 21. 28x. The one on the right, we're going to multiply top and bottom by 4x. Well, 1 times 4x is 4x over 28x. Now, at this point here, we can subtract the numerators, and well, they don't have anything in common. They're not like terms, so we would just have 21 minus 4x, or we could say negative 4x plus 21 over 28x. Because 4 and 21 do not have a greatest common factor, there's nothing that will go into both 4 and 21. And because these are, in either case, stuck together, there's no way we can use it to reduce with the 28x. The only possible way that we could is that if I take these two and split them and then simplify. Well, if we did that, we would actually be back to what we started with. So that here, either one of these is the correct answer. Now the negative in front of the x, we'll leave it there. It's not going to be that big of a deal or importance. The only way I would worry about factoring the negative out is if the denominator was negative as well. Any other questions on this here? Okay, because I think we have a few more. How are we feeling with these here? Feeling comfortable so far? Let's look at this one here. because I think this here will really drive the rest of this home with solving these, or really simplifying these expressions. Now, when we look at these three here, we need to get the denominators to be the same. So the numerators, x minus 2, as I look at this here, as we're writing this, we'll need to leave a little bit room in the middle, because we can see that the middle ones needs to be changed as well. And 5x. As I say that, I realize I didn't even leave space for the first one. So since I had 3, I left space to the left of where I started for the first one, to where I can get the denominators to be the same. I left a little space in the middle for the middle one, and then we have a little space to the right. So when we do the multiplication on top and bottom, I have space to fill it in. Well, the middle one, x, well, that's not going to factor. That's already as simplified as it gets. Can we do anything to the x minus 4? Well, we can't. Yeah, the x squared minus 16, we can factor it. The x minus 4 we can't, but incidentally, for x squared minus 16, one of them is x plus 4, and the other one's x minus 4. So, well, we're going to have to multiply all 3 by something, because we need all 3 of these denominators to be the same. Now, which one we start with really doesn't matter, because we need them all 3 to be the same. So we can start off with the one that just has x minus 4. So what is it missing that the other 2 have? Yeah, we'll need a single x, because the middle one does have x by itself, so it's going to need an x. And an x plus 4. Because the single x will get it to be the same as the middle, and the x plus 4, if we get it as well, will help it be the same as the third. So x times x plus 4 will help the first one to be the same as the other 2. Now the middle one is missing what? X minus 4 and x plus 4. It's missing both. And what is the last one missing? It's a singular x. So with that, the denominator for all 3 of these here is going to be x times x minus 4 times x plus 4. Yep. I had a feeling I was going to do that. So denominators across all these, x times x minus 4 times x plus 4. X times x minus 4 times x plus 4. X times x minus 4 times x plus 4. Now, out of all 3 of these here, there's only one of these we're going to multiply all together, all at once in one step. Which one do you think that's going to be? 5x times x is? Because the other 2, it's going to require a step or 2 to actually multiply it all out. It would be a little much to try to multiply x times x plus 4 times x minus 2 all in one step. It's a little too much to do all at once. The middle one, we can actually cheat in quotes a little bit in that multiplication. I'm going to write the 2 down. But doing x minus 4 times x plus 4, well, where did we get both of those from? Okay, I'll use a crayon. We got it from this here, yes? Okay. Well, why not use that to our advantage? Because the top here is x minus 4 times x plus 4. Well, we got it from x squared minus 16, so I can fill that back in. There's no real point to multiply using the distributive property. Do x times x, x times 4, negative 4 times x, and negative 4 times 4. Since we know it's supposed to go back to x squared minus 16, that's where we got the factors from. Now we have the last one over here. There's different ways we can do the multiplication here. Because we could start off with doing x times x plus 4 first, or we could do the x plus 4 times our x minus 2, and do it in any order we want. I have a feeling y'all want to do just the x times x plus 4. It's not going to be any way about it. It's going to be about the same. Because if we do x times x plus 4, well, x times x is, and x times 4 is. Because it's going to be one of those, we'll have to do it eventually. It's just deciding how we want to go about it. Make that a little bit longer. X times x minus 4. Now again, it might be very tempting to want to rewrite the x minus 4 and x plus 4 on bottom back as x squared minus 16, but we'll want to leave it factored, because if it works out that the numerator does have a factor, greatest common factor of x, or it can be factored with an x minus 4 and x plus 4, well, then we would have to factor it back out to be able to simplify. Well, why don't we do the middle one? Well, we're going to distribute the 2. So 2 times x squared is 2x minus 2 times 16 is negative 32. Okay, that's not too bad. Now we can use our distributive property on the first one here. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. 4x times x is plus 4x squared, and 4x times negative 2 is negative 8x. Luckily, we do have a good bit of paper for this here, yes? Okay, let's make this a little bit easier, because we are going to need to combine like terms, yes? All three of these are addition, yes? So is the sign going to change on any of them? No, okay, well. Let's go on and put them all together. So in the first part, we do have our x cubed. Here, the negative 2x squared plus 4x squared is going to be plus squared minus 8x plus 2x squared minus 32 plus 5x squared. Now, realistically, at this point here, we could have also gone on and just added all the x squareds together and all the terms with x together, but it turns out we only have x squared in common with all three rational expressions. But we can go on and do that in the next step, if it'll let me. And not try to scroll up the page. Okay. Something is registering as touch. So we'd have x cubed. Now we have 2x squared, 2x squared, and 5x, yes? So plus 9x squared minus x minus over x times 4 times Yep. And we get this here. Now we would see if there is a way that we could factor the numerator, which there does not seem to be, because as long as I got all the signs correctly, this here looks like it'll be it, because x cubed and x squared do have a greatest common factor of x squared. And negative 8x minus 32 does have a greatest common factor of negative 8, but factoring either one of those there does not give us a way to actually simplify, because we would need the sets of parentheses to be the same. So I'll write this out to the side, because if we did that, we would have x plus 9, and then negative 8 times x plus 4. Well, because of that being a 9, we can't actually combine them. So this here would be the final answer. Now, if it actually worked out to have been plus 4x squared, we could have actually done something with it. But unfortunately, we're not able to. Any questions on this here? If I'm in the right section. Oh. Try this one more time. 25. Yep. Okay, yep, that would be it. Okay. Yeah. This is the correct answer, but I did notice one small thing. I managed to change this from a minus to a plus. But if they were all plus, we would get this here. Okay? So, any other questions on this here? So, on your note sheet, if I can get back to the top and it would let me stay here, go on and change that to a plus. That way, if you do look back at it to try to figure out what happened, you have an idea that it was supposed to be a plus and not a minus. Any other questions on any of this here? Right, select no. Homework. So this is the homework assignment for 7.41. It says here 392, 4 through 6, 8, 12 through 14, 20 through 23, and 26.